Good morning, boys and girls. I apologize for not being at school today. My daughter's sick, so I'm home with her. Hopefully we'll be back tomorrow. I do think that today's lesson is one that you can handle without me, that we should be able to get through it on a YouTube video. And then if you have any questions, I'd be happy to answer them tomorrow. Today we're going to talk about surface area of rectangular prisms. The notes packet you received is for today and tomorrow. So we're not doing the whole packet today. We're focusing just on rectangular prisms. So you'll remember from yesterday that the definition of prism is that it has two bases, and we know what those bases are just from the name. So in the case of a rectangular prism, the two bases are both rectangles. And then we also learned yesterday that with prisms, all of the other faces are also rectangles. So in a rectangular prism, our life is good because all six sides are rectangles. So we really only need to use the one formula for rectangle. We'll still have to figure out the area of all six sides. And then when we do that, we call that the surface area. So for number one, we'll fill in the blank here. The surface area of a solid is the sum of the areas of all of its faces. And so what that means is we're going to find the area of all six rectangles, and the sum, of course, meaning we're going to add them together. Number two relates to what we looked at yesterday. A net is a two-dimensional representation of a solid. So we talked about how when you unfold a three-dimensional shape, it becomes two-dimensional. And so if it helps you to kind of imagine the nets when you are finding surface area, then you can kind of draw that out. I find that with rectangular prisms, it's actually easier to try to imagine the three-dimensional version. But if we want to refer to the net, that's fine. Okay, so in number three, you can use the net, just as I said, to find the surface area. And then lastly, surface area is measured in, and this might surprise you, but it's measured in square units. We think about surface area, remember it's still just area. We can flatten out a three-dimensional shape and still make it two-dimensional. A lot of times when we start getting into three-dimensional, we want to cube those units. That's not till we get to volume. We'll talk about that on Friday. Okay, so let's take a look at our first rectangular prism. You'll see here, and I know it's kind of small, so follow along on your notes, but you'll see here that we have a rectangular prism with three dimensions on it. There's a 7 inches along the bottom, there's a 4 inches going toward the back, and then 3 inches going up. So when we go to label those, the 7 inches we call the length, the 4 inches we call the width, and the 3 inches is an obvious one, there's the height. Okay, when we look at the net, they're a little harder to find which one is the length, the width, and the height. But I did want to show you what that looks like when it's all stretched out. That again, we are finding the area of all 6 rectangles, and we're going to put that together to find the surface area. So what I like to do is I like to make a table because then I can keep my thoughts organized, keep my work organized till I'm ready to find the surface area. Most importantly, you need to recognize that the top and the bottom of the rectangular prism are, of course, the same. The front and the back of a rectangular prism are the same, and the left and the right are the same. So once you find the bottom or the top, we can just multiply it by 2, and we've got the area of both. Once we find the front, we'll multiply by 2. Once we find the left, we'll multiply by 2, and we'll put that all together to find the surface area. So our work is going to look a lot like when we did composite figures last week. So first things first, we always write the formula. So since these are all rectangles, we're going to start with area equals length times width on all 3 columns. Okay, and this is where I kind of wish I was with you so we could kind of talk through where the length and the width are for each of these parts. But just kind of follow along. I think you'll be able to find this. So imagine, the top and the bottom of this rectangular prism Imagine it's a present or a box you received on the front doorstep, and where the bottom is, where the top is. So in this case, if you want to get out a highlighter and you want to kind of color in where the top and the bottom is, I think that sometimes helps. So the top and the bottom in this case, we are looking at the length and the width of 7 and 4. You can see that rectangle is laying down, and so it is 7 inches long and 4 inches wide. So we're going to go ahead and rewrite that as A equals 7 times 4. And of course, that's 28. And since that's the bottom, we want to multiply that by 2 to get our total area for both the top and the bottom, which is 56. Okay, this is what I want your work to look like. Formula, substitution, answer, and then show me that you're going to multiply it by 2. We don't have to put in labels yet because we haven't finished our problem. Now, when we look at the front and the back, this is where I would suggest looking at trying to imagine which one is the closest to you, which one of those rectangles, which one of those faces is closest to you. Now, be careful here. We still used length and width because they're all rectangles, but in this case, our length and our width of the front might actually be the height that we just labeled here. So the length of the front, I would say, is 7 inches, and the width, remember, you're looking just at the front, is that 3 inches. And so we multiply that together, and of course we get 21. We need to multiply by 2 to get a total area for the front and the back of 42 square inches. And lastly, the left and the right. These are often the hardest ones to find. Again, this is where a highlighter might be helpful. The length and the width there are the 2 remaining dimensions that need to multiply together. So I would say the length is that 4, and then the width is the 3. You're looking at the 2 dimensions that make up the left and the right. So 4 times 3, which gives us 12. We're going to double it for a total area for the left and the right of 24. So then at the bottom of the table, I'm going to put all that in there. So the 56 plus the 42 plus the 24. And if we real quick solve that out, we're going to end up with 122 square inches. Sorry about my kitty. At this point, if you want to pause the video and discuss as a class, if you have any questions, feel free. If you're all feeling pretty good, we're just going to go ahead and we're going to look at the second one. Very similar. Okay, so in this case, we're looking at a tissue box. Still considered a rectangular prism, but this one's actually sort of unique. The base of that rectangular prism is 5 by 5, so we might actually call this a square prism. It's not quite a cube because not all 3 sides are the same, but we would call it a square prism since the 2 bases are squares. So we're gonna have to be a little careful with our formulas here, but it really doesn't matter because, as we talked about last week, a square is an example of a rectangle. So if you didn't catch on that it was a square, that would be okay. The other thing here is, I know we get a little scared when we see fractions and mixed numbers. If you feel more comfortable changing that 6.5 to 6.5, that's fine. Just be careful with your decimals. Okay, so top and bottom, again, all 3 of these we're looking at rectangles, but since the top and the bottom are squares, I'm going to be more specific and do A equals S squared. But the other 2 are definitely rectangles, so we'll do length times width on those. Okay, so for the top and the bottom, both sides are 5 inches. So we're going to substitute in 5 squared, and our area is 25. We'll double that for the top and the bottom to get 50. Okay, for the front and the back, we have a length of 5, and then you kind of have to imagine what's the closest side to you in that tissue box. So when we look at the 5 is, I would say, along the bottom, and then along the width really is going up is that 6.5. I know we're all a little more comfortable with decimals than fractions, so I'm going to change it to 6.5. Okay. And when we solve that out, I'll just go ahead and share with you that is 32.5, We, of course, need to double it. And we get 65. Now, here's the cool part. The left and the right is exactly the same as the front and the back. That's what's nice when we have a square involved. So it's still going to be 5 times 6.5. For an area of 32.5. And we'll double it to get 65. So last step then, of course, is to find the sum. So we're going to fill in the 50 plus 65 plus 65 for a total surface area of 180 inches squared. Okay. All right, there are 2 more rectangular prisms. I think that's this page and then on the next page. I want you to pause the video. With your group, I want you to work through those 2 surface areas. Make sure you are showing your work formula, substitution, area, then show you're doubling it. And of course, along the bottom, fill in, find the sum, and put a label on it. So take a few minutes, work through those, then we'll share some answers. Okay, hopefully you've paused the video and worked through those problems. I'm going to go ahead and just put up the answers, of course, as a class. If you're not agreeing or some things, you're not sure why an answer is, please talk through those as a class. You can pause the video if you need to and discuss any of these. So here is the first one. So hopefully you were able to tell that the base of that rectangular prism was 13.4 and 1.2. That's always a hard one. It's not 12. That decimal is hard to see. So along the top and the bottom, we're going to do the 13.4 times 1.2, double it, and we end up with 32.16 for the top and the bottom. For the front and the back, I did 13.4 times 4, double it, and I ended up with 107.2. And on the left and the right, 1.2 times 4, double it, and I ended up with 9.6. Add it all together, and hopefully you got 148.2 meters squared. Pause if you need to discuss that one. And then for the last one, top and the bottom, I did the 7 times 3 and end up with 21, so we double it for 42. For the front and the back, 7 times 5.4 and double it to get 75.6. And on the left and the right, the 3 times 5.4, double it to get 32.4. Along the bottom, we'll add all those together and end up with a total surface area of 150 centimeters squared. And again, pause if you need to discuss that one. Okay, so this is how I would like you to show your work on your eye and on your homework tonight. But I do want you to take a few minutes and brainstorm with your group. If you go back to the very first rectangular prism we did, we labeled in that picture length, width, and height. And we really never used the letter H because we were looking at just the 2-dimensional rectangles. But we labeled over here length, width, and height. I want you to brainstorm with your group. Is there a formula for surface area of a rectangular prism where you use the letters L, W, and H, where maybe we wouldn't have to set up all these tables and find all these different numbers and find the surface area, but instead, just like where we did with the parallelogram and found A equals B times H, or with a square, A equals S squared. Is there a formula for surface area of a rectangular prism? Take a few minutes, brainstorm, write down your thoughts on your notes with an empty space underneath that last rectangular prism. We'll talk about it first thing tomorrow. I'll be impressed if anybody figures that out. Okay. All right, so last thing I need to tell you is your eye assignment. I know it's not written on the board, so here it is. Pause this video, write these down, and get started on your independence. Have a good day.